In today's video, we're going to be talking about Physics 252, Week 6, problem number 4. In this problem, we are asked to relate different waves along the electromagnetic spectrum to one another, mainly using frequency. So as we go through this problem here, it's talking about microwaves and fiber optics. This is just kind of two different ways that we transfer information using the electromagnetic spectrum, and we were just kind of asked to relate frequencies and speeds of these two. So starting off, it asks us for the frequency of a microwave with a 3 centimeter wavelength. So if we remember from lecture, specifically our lecture on light, we're given this equation right here. And this equation is very important for these types of problems. It uses the speed of light, the speed at which all the waves on the electromagnetic spectrum travel, to relate wavelength. So based on their change in speed, because sometimes they're hindered through different mediums, but mainly from their change in wavelength, we get different frequencies of the wave. So if we look at this image here, it kind of gives us the hertz and the wavelength that we suspect. So as we can see here are microwaves, but what we can do is we can just go ahead and plug in our speed of light and our wavelength here to get our desired frequency in hertz. And if we see here, this is 10 to the 10, so this is what we would expect. For B, we are asked to find the frequency of light used for fiber optics. So we're given that the laser wavelength is about 1 times 10 to the negative 6. So what we can do from here is we can just do the same thing that we did above, plugging in C and our wavelength to get 3 times 10 to the 14 hertz. From here, it asks us for the ratio of the two frequencies. So if we just put one over the other, we're given this number here, 3 times 10 to the 4th, and this could be unitless because it's a ratio, but yeah, so that's the relative rate that the information is transmitted. And if we go to D here, we're asked to see how long it would take a microwave to travel 100 kilometers, which right here is, this is going to be our equation from above, just rearranged. The difference here is that we're taking the distance over the velocity. So when we take distance over velocity, we can just kind of cancel the meters here, and we're left with seconds. So from here, we can use this little equation given in the problem here, and we can plug in our C to get this number here. So this is how fast a laser would travel through glass, and or light would travel through glass rather, and then we can do the same thing where we put the meters over the meters per second and get the meters to cancel, and we're left with seconds here. So this would be the time that it takes the laser to travel this distance, and then as far as the difference, we can just subtract the two from one another, and this is how much faster the laser would travel than the microwave. So not a huge difference, but it definitely makes up, definitely can make up some time, you know, if you really got to get something to load. So I hope you guys found this video helpful, and thank you very much for watching.